Coulomb's law states that electrostatic force between 2 point charges is F equal to Q1 Q2 over 4 pi epsilon R square, where Q1 Q2 are the charges. R is the separation between the charges. Epsilon is the permittivity of free space, with epsilon equal to 4 pi times 10 to the power negative 7 Coulomb square per meter square per Newton. Remarks 1. Electrostatic force between light charges is repulsive, and that between a light charge is attractive. Notice that electrostatic force is a vector quantity. Third, electrostatic force are action and reaction pairs. That means force on 1 is equal to force on 2 with their directions in opposite side. Look at question number 1. Applying the equation, electrostatic force equal to Q1 Q2 over 4 pi epsilon R square. For the first set, we have F equal to 3 times 2 over square of 1 times 9 times 10 to the power 9, which is equal to 54 times 10 to the power 9 Newton. For the second set, notice that 1 μC equal to 10 to the power negative 6 Coulomb. Therefore, F equal to 5 times 10 to the power negative 6 times 6 times 10 to the power negative 6 over 0.01 square times 9 times 10 to the power 9, which is equal to 27 Newton. Now look at question number 2. First, calculate force between xy equal to qx qy over 4 pi epsilon r xy square, and F between xz equal to qx qz over 4 pi epsilon r xz square, and force between yz equal to qy qz over 4 pi epsilon r yz square. Therefore, Fxy equal to 18 times 10 to the power 9 Newton, and force between xz equal to 6.75 times 10 to the power 9 Newton, and force between yz is 54 times 10 to the power 9 Newton. By drawing the force act on x due to y and z, therefore, the resultant force on x is equal to Fxy plus Fxz, which is equal to 24.75 times 10 to the power 9 Newton. Next, by drawing the force acting on y due to x and z, we have the resultant force acting on y is 54 times 10 to the power 9 minus 18 times 10 to the power 9, which is equal to 36 times 10 to the power 9, pointing to the left. Now look at question number 3. There are tension Tx and tension Ty on X and Y respectively, and weight mxg and weight myg. Also, there are electrostatic force acting on X and Y, Fx and Fy, along the line joining xy, and the force are repulsive. Also, Fx equal to Fy equal to Qx Qy over 4 pi epsilon r xy square. By taking moment at point P, we have total clockwise moment equal to myg times 0.1 equal to the total anti-clockwise moment equal to mxg times 0.3. Notice that there is no moment of the tensions above P because both Tx and Ty passing through P. Also, the electrostatic force Fx and Fy when taking moment above point P are cancel each other. As a result, we have mx over my will be equal to 0.1 over 0.3, which is 1 over 3. Therefore, Y has 3 times of greater mass than X. Question number 4. Force between xy equal to Qx Qy over 4 pi epsilon r xy square equal to 2 over square of 1 times 10 to the power 10, which is equal to 18 times 10 to the power 9 Newton. Force between xz equal to Qx Qz over 4 pi epsilon r xz square equal to 1 times 3 over 1 square times 9 times 10 to the power 9, which is equal to 27 times 10 to the power 9 Newton. Consider the sign of the charge acting on X, Y, and Z. We can draw the direction of the force acting on X due to Y and that of the force acting on X due to Z properly. By resolving the force acting on X into horizontal and vertical component, and then we add the sum of the horizontal force and vertical force. The resultant horizontal force act on X are Fxz cosine 60 degree plus Fxy cosine 60 degree, and the resultant vertical component acting on X is equal to Fxz cosine 30 degree minus Fxy cosine 30 degree. Finally, use perpendicular theorem, you can find the resultant force acting on X using the sum of the square of the horizontal component and vertical component, and use the square root to find the answer. Question number 5. Before they are touched, the force between X and Y equal to Qx Qy over 4 pi epsilon r square, which is equal to 16 Q square over 4 pi epsilon r square. when they are brought to touch each other and then placed back to their original positions, the charge on X and Y are the same, which is equal to 3Q with the same separation out. Now the force between XY becomes QX QY over 4 pi epsilon R square, which is equal to 9Q square over 4 pi epsilon R square. Therefore, the force now is equal to 9 over 16 F.